In this set of videos, we'll be discussing division. But before we talk about the process of division, let's talk about what division actually is. Division is the process of splitting a group into a series of equal numbered elements. It can further be explained as the inverse of multiplication. For example, if we divide 10 into two equal groups, we will have 5 elements in each group. Now, you may notice, to say that 2 groups of 5 gives us a total of 10 is in a way saying the same thing. The first way we describe this scenario is from the standpoint of division. 10 divided by 2 gives us 5. The second scenario is from the standpoint of multiplication. 2 times 5 gives us 10. In this way, any fact that we obtain from division can be rewritten as a multiplication statement. So for example, 12 divided by 3 equals 4 corresponds to 3 times 4 equals 12. But why does this work? Let's look at the operations of multiplication and division a little more closely. Multiplication, in its simplest form, can be defined as the repeated addition of groups of the same number of elements. For example, if we look at 3 times 4, which we know to be equal to 12, this can be described as 3 plus 3 plus 3 plus 3. But what if we begin with a group of 12 and wish to separate it into groups of 3? Here, instead of adding together numbers, we're wishing to divide them up, which we can do by subtracting them from the initial group. So from our initial number of 12, we separate a group of 3 by subtracting it, which leaves us with a group of 9. Here, we can subtract another group of 3, leaving us with 6, from which we can subtract yet another group of 3, which leaves us with a final group of 3. So now we can see that we have 4 groups of 3. Or in other words, 12 divided by 4 is equal to 3. 3 in each group. So what does this show us? If 12 can be composed of 4 groups of 3, and 12 can be decomposed into 4 groups of 3, then we know that the operations used to compose and to decompose numbers must be opposite. In other words, because we know there's an inverse relationship between addition and subtraction, and because we know that multiplication and division can be explained with the help of addition and subtraction, we can see that multiplication and division must be inverse operations. So how is this inverse relationship between multiplication and division represented? If we're wanting to divide 12 into 4 groups, we can represent this as 12 divided by 4 is equal to blank. Or we can say 4 groups of how many equals 12. Or, as we just learned, we can say 4 times blank is equal to 12. So in this way, the inverse relationship between multiplication and division can help us to solve these problems by phrasing or rewriting them in reverse. In these videos, we will be using some common vocabulary which is important to understand before we begin. The number that we are wishing to divide is labeled the dividend. In our last example, our dividend would be 12. The number by which we are dividing is called the divisor. The solution, or the number of times the divisor can be multiplied into the dividend, is labeled the quotient. In some cases, the divisor cannot be evenly multiplied into the dividend. In this case, you'll end up with some whole number left over that is smaller than the divisor. This is labeled the remainder, which we will explain in more detail in later videos. Division problems are traditionally represented in one of 3 ways. The first of which, with the dividend being placed on the right of the right parentheses vinculum, with the divisor on the left and the quotient up above. The second way is to represent it fractionally, with a dividend placed over the divisor and the quotient separated by an equal sign. The third way is to have the dividend placed on the left of the obolus, with the divisor on the right and the quotient separated by an equal sign.